Right, so let's move on to the next concept in stoichiometry, and we'll be finishing off here. This is the last concept, and that is concentration. Okay. अच्छा, अब concentration जो है ना, we usually calculate for solutions. ठीक है. Aslan, can you tell us what is a solution?
It's a liquid with uh, it's a liquid type of with concentration.
Okay, सही है. So yes, a solution is a liquid. ठीक है. It can be an aqueous liquid, or it can just be a liquid. A solution can be a dilute solution, it can be a concentrated solution, it can be a suspension, right? It can be a super saturated or saturated solution. बहुत सारे different types of solution होते हैं, right? But one thing which is common in all solutions is that a solution contains a solute, right? And solute dissolves in the solvent. So a solvent is usually a liquid, right? What is a universal solvent? Universal solvent is water. Okay, water में mostly सब कुछ dissolve हो जाता है. Not everything, but mostly. So solute and solvent make up solution. ठीक है, when you just dissolve them together, that makes up solution. ठीक है, that makes up solution. So if you want to know that what like how much mass per unit volume of solute does this solution contain? So basically that is known as the concentration. So concentration क्या होती? It is defined as the mass per unit volume, mass per unit volume of solvent, sorry, of solute that is present in the solution. Okay, so you just divide the mass of solute and the volume of solvent, and then you get the concentration of the solution. Okay, pretty simple. In stoichiometric calculations, the concentration is usually expressed as mole per decimeter cube, right? So you'll be using that a lot in your calculations. Okay. And this concept is critical for understanding how strong or weak a solution is. So for example, if a solution is really concentrated, if it has a very high concentration, so it is a strong solution. And if it has a low concentration, so it is a weak solution. So yeah, pretty trivial, right? So let's move on. So this is the formula to calculate the concentration. You need to divide the moles of the solute, right? And the volume of solution in decimeter cube, and then you get the concentration in mole per decimeter cube. So yeah, right. And one important conversion factor that you guys need to know is that 1 decimeter cube equals 1,000 centimeter cube. Okay, usually we measure volumes in centimeter cube, right? So you'll be needing to convert centimeter cube to decimeter cube, right? Simple mathematical calculation and division multiplication. Okay, so let's look at an example. Calculate the concentration of a solution containing 10 grams of sodium hydroxide dissolved in 500 centimeter cube of water, right? Okay, so Aslan, what was the formula to calculate the concentration? Moles of the solute divided by
Mass?
the
Yeah.
volume of the solvent, right? Not the mass, the moles. Okay, if you want to get the concentration in moles per decimeter cube, you'll convert the masses into moles first, and then you'll divide it by the volume. Okay, so what steps should I follow here to calculate the concentration of the sodium hydroxide solution? I have 10 grams of sodium hydroxide. I can't hear you.
Hear me now?
Yeah.
1/50.
What? 1/50? Nahin. You know the mass of sodium hydroxide, right? So you have 10 grams of sodium hydroxide present. And to get the concentration of this solution, where you dissolve 10 grams of sodium hydroxide in 500 centimeter cube of water, you'll first convert 10 grams into moles of. So how many moles of sodium hydroxide in 10 grams? So 10 grams divided by the mass of sodium hydroxide, the molar mass of sodium hydroxide. And that is equal to 40 grams. Okay? That gives us 1/4, and that is 0.25. So 10 grams of sodium hydroxide is 0.25 moles of sodium hydroxide, right? And you have 500 centimeter cube of water, right? So see right here they have done. So first of all, we calculate the moles of sodium hydroxide, right? So that is 0.25 moles. And you calculate the volume of the solvent in decimeter cube. So we had 500 centimeter cube of water. Using that conversion factor, we just divide 500 centimeter by 1000 and you get 0.5 decimeter cube. And then to calculate the concentration, you use this formula, that is the moles of solute you have, and you divide by the volume of solution in decimeter cube. So 0.25 moles of sodium hydroxide and divided by 0.5 decimeter cube of water. And that gives you 0.5 moles per decimeter cube of sodium hydroxide solution. Got it?
Okay.
Okay. So that's how you calculate the concentration. Acha, one more formula that you need to know for the concentration is that the moles equals the concentration times the volume. So if you know that, if you know the concentration of the solution, for example, if your concentration is 0.5 moles per decimeter cube, right? And you have the solution and you have like 500 or you have like 50 decimeter cube of that solution, right? So what will be the moles of solute in that solution? So in order to calculate that, just multiply the concentration by the volume of solution you have, right? And this gives you 25 moles. That's a lot, but that gives you 25 moles. So remember this formula. This is really, really important, and this will be used in most of your stoichiometry calculations. So the moles equals the concentration of the solution times the volume of solution you have, right? That ends the lecture today.